Hi, everybody. It's just about 1 o'clock, so we're going to get started. I see some people on the line. I heard there was something a little bit different to sign in. They wanted a Reg ID. I apologize if that was a stumbling block for anybody. If you have anybody else trying to join, I did just send out an email showing people where that Reg ID can be found in your original email from WebEx. So thanks for being patient with us as we work through that new option that was just kind of came up last minute on us, but thanks for being here. This is our third webinar of 2025. We've done a couple earlier this year on sprinklers and foam. This one today is on antifreeze. I'm Jenny Novak, and I'm the marketing manager here at Dyne, and I help coordinate the webinars. So if you need anything before or after a webinar, you can reach out to me, and I'll have information in the follow-up email that'll go out following the webinar. Welcome back if you've joined us before. We have a record number of attendees. Antifreeze is usually not as highly popular, but we have quite a few registered, so thanks for all of your participation today. A quick intro about us. Dyne's an independent testing laboratory. We've been doing firefighting foam for over 25 years. We also test dry chemical agents, sprinklers, and antifreeze, which we're going to be talking about today. Last year, we were acquired by Global Solutions, and as you might know, we've been doing some rebranding while we've continued to provide the same fast and reliable service and quality test results. We're always asked if we're certified or accredited. Dyne is ISO 9001 certified and has a 17025 accreditation by HOLA for our automatic field sprinkler testing. Just a little housekeeping before we get started. If you have any questions during the presentation, you can type them into the Q&A or the chat window, and we will save them all up till the end and have a Q&A session. Stay to the end of the webinar and receive a certificate of attendance. A lot of people ask about that. I do send a certificate of attendance. If you need to use it for any type of credit applicable, some people are using it for NICET. I believe we are a NICET approved provider. So that'll come out either today or tomorrow morning. Some people like to use the follow-up link on our recording to share it with others or rewatch it. That will also be available. So today's webinar, Antifreeze Testing, will be presented by Grant Lobdell, who's the president at Dyne. He has an extensive knowledge of firefighting foam, sprinklers, dry chemical agents testing, as well as antifreeze and 25 requirements from NFPA. Now I'd like to turn it over to Grant to talk to us about antifreeze today.
Thank you, Jenny. Some quick disclaimers before any further. Any opinion expressed in this presentation is the opinion of the author, myself, and does not necessarily represent the official position of NFPA or its technical committees. As Jenny mentioned, we were acquired by NFPA Global Solutions a little over a year ago now. As a result, we did give up our positions on the technical committees. That would be seen as a conflict of interest. So if you want to get the official position of NFPA or its committees, you can reach out to nfpa.org, find the standard or that you're interested in, and there's a button, there's a link right in there to request an official interpretation. Other disclaimers specific to this antifreeze is that the use of antifreeze solutions shall conform with state and local health regulations. All right, with that out of the way, let's start right off the top of why are we even here? Why are we talking about this? Obviously, it is required in NFPA 25. When I mention NFPA 25 today, I'm going to talk about the 2023 edition. That is the most current edition, at least for a few more months. The next edition, 2026, will probably be released in a few months if they follow the typical release schedule. And then we'll have a 2026 edition to look at. Now, I realize many of you listening, you may be in a jurisdiction with, maybe you've only adopted the 2017 or 2020 edition. I will try to call out some differences where I can, but most of the changes that have been happening over the last few years, they've been in the last several editions. So we know that NFPA 25 says it shall be tested, but why is that? We don't want to do this just because a document says we have to do it. Let's understand the deeper meaning of why it's in there. When we talk about antifreeze solution, why is it in the system? Really what we're trying to do is prevent water from freezing, right? If we have cold temperatures, if we have freezing temperatures, then we are going to possibly have burst pipes, right? As water freezes and when it turns to ice, it expands. We could then have burst pipes, which can lead to water damage, just costly damage we're going to have to repair. So one way you can try to avoid this situation is to use antifreeze. There are some other ways, and we'll talk about those a little bit later. But that's why we're putting antifreeze in the system. So we got to make sure every year, and we'll talk about frequency in a little bit, we want to make sure that we have adequate freeze protection. So if I go down to -20 in my area, I got to make sure the antifreeze in there still is going to perform, is going to not freeze down to -20. So that's one reason we're looking at. We're looking at the antifreeze that was put in. Is it still there? Is the concentration still sufficient? If it's too low, we could end up with burst pipes. And if it's too high, you can actually end up with ignition risk. And this is actually what caused a lot of changes in the last several editions to the code. Is there was this incident where an individual perished because sounds like it was twofold, the report. Concentration in the system was too high, and the system was under quite high pressure, so it atomized the droplets coming out. But too high, antifreeze is usually either glycerin or propylene glycol. Those are flammable liquids by themselves. Now we mix them with water and we try to reduce that effect. But if the concentration is too high, you could actually fuel the fire. That could be a dangerous situation. If you want to know more about this ignition risk that I'm talking about and these high concentrations, the Fire Protection Research Foundation has a great paper out there just titled Antifreeze Solutions Supplied Through Spray Sprinklers. In this report, it dives into much more in depth of how antifreeze could actually fuel the fire if not maintained at the proper concentration. And last but not least is improper type. We want to test to make sure we have the right antifreeze in the right system. We'll talk about this a little bit later, but CPVC, we don't want to have propylene glycol in those systems, right? That is an incompatible material. We could end up damaging and, again, having costly repairs. So while the document says we need to test this, the deeper reason behind that is, again, we want to make sure the concentration is effective, make sure it's safe, make sure it's compatible with what we have going on. So now that we understand why it needs to be tested, let's talk about when to test this. So you guys get, okay, I get it, Grant. I know it needs to be tested. When am I supposed to do this? The standard says that you should do this annually toward the beginning of the heating season prior to the onset of freezing conditions. So that's a mouthful right there. Annually, we're going to test it once a year. And I've underlined toward the beginning of the heating season because that is a new phrase that was added to the most recent edition. Prior to the onset of freezing conditions is all the wording had in 2020, 2017. So annually, you're going to do it right before we get in those frozen conditions, right? Before we could potentially have a problem. Why did the committee choose to add that other phrase toward the beginning of the heating season? I believe that was just to eliminate the potential that someone's going to test it too soon, right? Prior to onset of freezing, great, but hey, it's April, May, it's not frozen yet. That's prior to the onset. Well, now that's 6 months in between when it could freeze. Something could happen in between there. So they kind of narrowed the scope a little bit. When you start having the heat, you drop down, you're getting the 50s, 40s. We want to probably get that antifreeze tested, make sure, again, it's the proper concentration, it's going to be safe and effective. So that kind of gives us some backbone of what brought us all here today, why it needs to be tested, why it's in the document, and when we're supposed to test it. So now comes to, let's talk about how are we actually going to do this testing. It actually all starts with first reviewing the information available to you. The document NFPA mentions several things you can refer to. The easiest would be the antifreeze information sign if available. This is a requirement that actually shows up in Chapter 4. That should identify, okay, in this system, we have this type, this brand, this concentration within this system. If you don't have that, let's see if we can find some other installation or maintenance records. Let's talk to the building owner. Hey, did you put antifreeze in? Are you aware of this? What did they put in last time? Of course, you can rely on chemical tests. That's what we're going to get into a little bit later today. Or any other information. We're just trying to figure out what do we think is in there, right? So that's actually where you're going to start. Based on that information, if you already have reliable information that says, I already know this antifreeze installed here is not permitted, or there's just no way, there's no way we can tell, we can't determine what type this is, even with chemical tests, then you just need to drain and replace that antifreeze solution. There is no need to test, right? So that's why we start with the information phase. Let's figure out what we're supposed to have in there. And if we already know that there's no point in testing, then you do not have to. You can go straight to replacement. All right. And I mentioned on here, shall be completely drained and refilled with a listed solution. And again, you'll see permitted and listed in these quotes. The reason I did that is on a slide a little bit later to get into what those terms mean. And then we'll talk about what you have to refill, the requirements on that. So let's go to step 3. So again, I'm going to take you back. We know why we got to test it. We got to review our information. Step 2 says if we already know you got to replace it, then no, you can go straight to replacement. Step 3 says though, if based on information, you think you have a permitted solution, and we're going to get into that a little bit later, then you're going to start to take your samples. All right. Your samples at minimum, and I've highlighted, it's going to be the top and the bottom of the system. Let's briefly just talk about why we're doing the top and bottom. Antifreeze solution, if it separates out, we're going to talk antifreeze solution is the antifreeze, the glycerin, the glycol, and water. If that is separating out of solution, which can happen, we're going to end up with pockets of concentrated flammable liquid, which is your glycerin or propylene glycol, and pockets of dilute water, which is going to end up freezing. You take the top and bottom because when it separates out of solution, the heavier antifreeze is going to go to the bottom. So typically, if you have separation issues in the bottom, you're going to find very concentrated antifreeze. And at the top, you're going to find this looks just like water. So at minimum, you're going to take the top and the bottom. And for a lot of systems, that may be sufficient. All right. But the standard does say if the most remote portion of the system is not the top or bottom, which typically a lot of people it'll be your most remote, the farthest point is going to be your top sample. If that's not, you're going to want to make sure you take the most remote. Again, we want to make sure this antifreeze solution is uniform throughout. All right, so if the top is not your most remote, that's another sample you might have to add. And as well, if the bottom is not your water supply connection, you're going to want to take that a sample near the water supply connection. We're looking for there near the water supply is, do we have any leakage, any mixing, any diluting of the antifreeze solution at that point? Again, I'll say it again. We're trying to make sure that solution is uniform throughout the whole system. So at minimum, top and bottom. If the most remote and water supply are not the top and bottom, you're going to take those as well. So you might be up to 4 per system. And then there's the fifth point there. If your system is greater than 150 gallons, you're going to add another test point every 100 gallons. So again, we got the top, bottom, most remote water supply. If it's a very large system, somewhere in between every 100 gallons, we're going to take another sample. Why? You're going to get sick of me saying this, but again, we want to make sure it's uniform throughout. We don't have any separation of solution. We don't have any dilution in any area. We want to make sure it's safe everywhere. It's not too concentrated. We want to make sure it's not too dilute. It's still going to be effective. We're not going to have burst pipes in this one corner of the system because it wasn't uniform there. So again, I like to just always reset ourselves. We looked at the information. We said, yep, this is a solution I think is permitted based on the information. We took our samples, minimum 2, top and bottom. Maybe we had to take a few more to meet those requirements. Now actually comes time to test the sample. So the standard recommends, as do all the manufacturers, you're going to check the sample either with specific gravity or density or refractive index. So one of those two things. This does not necessarily need to be done in a laboratory. You can do this in the field. You would just need a hydrometer to do specific gravity. It is, you can imagine like a little buoy. It's a little float you put in the liquid, and based on how far down it sinks and where it floats, you can tell what the specific gravity of that liquid is. Or a refractive index, it's a little handheld device. Usually you can get them, they fit in the palm of your hand. You put a couple drops of water on it, close the lid, it shines a light through it. And based on how that light refracts, it's able to tell you how concentrated it is. Now, sounds relatively simple. Many of you probably are doing it in the field. You have this equipment, you know how to use it, you keep it calibrated. One caveat I would say, there is equipment out there that will take the number, the specific gravity of the refractive index, and convert it to a percent concentration for you. Just make sure if that is doing that conversion for you, you know what type of antifreeze you have. The meter may assume you put some drops of your antifreeze on there, and the meter's assuming, oh, this is glycerin, it's converting it. But if it's propylene glycol, actually, you're going to get incorrect values. You're going to be off, right? So to be able to use some of those built-in conversions, you're going to need to know for sure what you have. If you do not know what you have, or you just want us to take on the liability, you can use a laboratory like ourselves to do this analysis. And this is the only time you'll really hear me plug our analysis. The rest of it will keep it informational. But our laboratory here, again, just like all our services, we offer results in 5 business days or less. You have free test kits, so you can go to our website and order these. You can call, you can email. In this case, antifreeze is just some bottles. You can request to put your antifreeze in and then ship it back to lab. That shipping in the contiguous US is included in the sample kit. So by all means, take advantage of that. Again, you have this equipment, but you got something, you just don't know what type it is, or again, you don't want to deal with testing it. You don't want that liability. Let us help you. I've included there on the bottom this listed antifreeze verification test in red. This is something unique to Dyne. I believe we're the only laboratory that is able to offer this, where we are able to tell if you give me a solution, I can give you a thumbs up or thumbs down on whether that is one of the listed products. We'll get into which ones those are coming up here in a little bit. So we're able to tell you thumbs up, thumbs down. I'm not able to tell you what exactly is in it. That's considered a trade secret. We're under NDA with manufacturers, but I can give you that thumbs up or thumbs down. For some of you, that may be useful. You may want to know, hey, this needs to be a listed solution. And you're not going to be able to tell by just looking visually at the sample. Some of these listed solutions, they look like water, okay? So that is an advantage. You won't be able to in the field, even with a specific gravity or refractive index, you won't be able to tell. So the last step in this, in the testing, again, let's reset ourselves. We verified the information. We think it's permitted, so we're going to grab our samples, top, bottom, if most remote and near the water supply are part of that, we're going to take those as well. We've either checked the solution's refractive index or specific gravity ourselves, or I've sent it off to a laboratory to do that. Now we get the results. What are we comparing it to? How are we determining pass fail? For that, we're going to look at the allowable range. All right. For a listed product, we're going to have a manufacturer data sheet. We're going to just compare our result to that. All right. For the legacy solutions, the non-listed products, I'm going to get into that in just a moment. We're going to compare that to a chart of known. Okay, at this concentration, we expect this refractive index or density. At this concentration, we expect this refractive. If I'm not in the allowable range, I need to replace that solution. So that's why we're testing it. I will say there's a caveat to that. While the standard says you're not in the allowable range, you need to replace. There's another reason you need to replace. That is, it does not provide the freeze protection you need. Seems obvious, but it is something to mention, right? So if you send us a sample and the standard says, hey, this is safe anywhere between 0% and 30%, and at 0%, you're getting no freeze protection, that may not be satisfactory for you, right? If it's an acceptable solution and concentration, but I don't know if it's acceptable in your application. So you want to make sure it's in the allowable range, plus let's make sure it gives you the freeze protection you need. So let's get into that. That's just very brief, how to go through the testing part of it. Let's get into the meat of it. What's a permitted solution? What are allowable ranges? Things like that. So a permitted solution, number one, the end all be all is a listed antifreeze solution. Okay, I'll get into what listed is in a moment. A listed antifreeze solution, if you are following any edition from, I think, 2011 all the way to 2020, if you're not following the most current edition, that standard says you need to be using a listed solution right now. They sunset out the non-listed solutions as of September 30th, 2022, according to those other editions. Again, there was an issue many years ago. They allowed manufacturers some time to figure out how we're going to get a listed solution. then there was some time we could change it over, and they gave a cutoff date of September 2022. All right. Now, according to the most current edition, which even if your state hasn't adopted, there's always an argument to be made that, hey, I'm following the most current information. The 2023 edition does allow non-listed solutions to remain in systems, provided they're in the allowable range. We'll get into that. But as soon as you need to empty it and refill it, you have to use a listed solution. So if they've created this, they've grandfathered in some non-listed, this even more time to change it out. They're saying, hey, we don't expect everyone on September 30th, 2022, everyone needed to drain their systems, refill it. It's just next time you need to drain it, that's when you're gonna have to use a listed solution. So I am today gonna talk about non-listed requirements, allowable ranges. Even though in those prior editions it said, hey, you can't use non-listed, there is this gap, there is this grandfathered in. Well, you still can let it remain in there until you need to drain it first, according to the 2023 edition. And what I've highlighted on screen is that you cannot install, I call them legacy solutions, non-listed solutions, right? So for some reason, if you need to install antifreeze solution, you do need to use a listed solution. What does it mean to be listed? That just means it's been evaluated by a third party. It's been tested, proven to be safe and effective. An example of a standard the industry uses right now to verify, to test that these are effective is UL 2901, antifreeze solutions for the use in fire sprinkler systems. So a manufacturer will have a product, hey, I'd like to sell this as antifreeze as a listed solution. UL will take that and evaluate it, go through a wide gambit of tests, not just a fire test, but make sure, see how it corrodes the system, see how stable it is in solution. Again, we don't want these to separate those out. I checked on Monday, the 18th, so just a couple days ago, I went to UL's website and I looked to see, well, what products are listed? What products have passed this test and are approved through that? There are 4 products, 3 manufacturers, 4 products. We have Lubrisol's Freeze Master, Noble's Firefighter Eliminator 1330, and then Tyco's LFP and LFP Plus. They have 2 different models of antifreeze there. What I've shown on screen in parentheses is their use temperature, but obviously consult the manufacturers and the data sheets for more information. There's more to it than just use temperature. You obviously want to look at, well, the compatibility with your components, minimum design pressure, system volume limitations, things like that. So a listed solution is always acceptable no matter what edition you're on. Right now, there are 4 products that meet that definition. Let's talk about allowable range. So the listed is just going to be on the manufacturer's data sheet. So I'm going to go back and forth now a little bit. If you have Lubrisol's Freeze Master, Noble's Eliminator, or Tyco's LFP, you're going to pull up their data sheet. And I'm showing on screen now, I went back a few slides, the Tyco LFP data sheet, 1680. I've just pulled a screenshot of a little chart in there that document all the manufacturers have great technical data sheets. They show you the parameters, they show you installation instructions. But what I've pulled out here is what we're concerned about today. Is we pulled our sample, we've tested it, we're going to compare. Either we've grabbed specific gravity or we've grabbed refractive index. What's the allowable range? For a listed product, it's right there on the data sheet. That's what you want to follow. So in this case, LFP, if you check the refractive, you need to be between 1.3960 and 3995. If your product or your solution installed in your system is not within that range, you would have to drain and replace that solution. And like I mentioned, if you're draining and replacing, you are now replacing with a listed product. It has to be. Now, if you have a non-listed product, again, there is a period here where you are allowed to let the non-listed product or legacy product remain in the system. You're still going to check the specific gravity or density or the refractive index, and you're going to compare it against a chart. What I've shown on screen is actually pulled right from the annex of 25. You could reference this if you would like. Manufacturers will also typically have these kind of conversion charts. So you could take, let's say, I believe I have a glycerin solution, and I think the density is, let's say it's 1.029. I look on my chart where I have, let me see here, I have a laser pointer, so I can point this out. 1.029, if that is my glycerin solution, if I'm sure of that. Again, you got to be sure of that. If not, let us help you figure that out. If it's glycerin at 1.029 specific gravity, I have a 10% solution. I have freeze protection. I only go down to 28 degrees Fahrenheit, so not very much freeze protection. While that's an acceptable solution, you can see here, non-listed, you're allowed to go up to 38%. That's only 10. That's an allowable range. But then it comes down to, is that 28 Fahrenheit, is that good enough for your freeze protection? So you would do something similar with, let's say I have propylene glycol. If I had the same specific gravity, 1.029, I'm looking at about a 36% propylene glycol solution, right? And that is not allowed, right? So this is where it's important that you know what you have. Because if you put your solution on there and you get 1.029, if it's glycerin, you're okay. Now, you're okay in the concentration wise. I don't know about freeze protection. But if it's propylene glycol, you have something that's no longer allowed. So that's why you have to be 100% sure you know what solution you have. So for your non-listed solutions, those are your requirements, less than or equal to 30 propylene glycol, less than or equal to or up to 38% glycerin. Again, if you are above that range, you now have to drain the system and replace the antifreeze. You cannot replace it with non-listed solution. You must use a listed product. With the one exception here that I'm going to bring up, if a listed product does not give you the freeze protection you need, let's go back to our products. Let's say you're in an area that needs negative 30 degrees Fahrenheit. There is no product available today that can go that low. What do you need to do? Well, in those cases, you got to look at alternate means of freeze protection. So we're talking about converting the system to dry or pre-action, or using listed heat tracing. That's another option. So unfortunately, there isn't solutions out there that'll solve every problem. I briefly covered it at the beginning. I'm going to go back to that slide as well. This is a chart also in the annex of NFPA 25, and I realize it might be kind of small. My intent is not to really dive into the details of this chart, just show you that it's there. This chart shows I believe the lowest one-day mean temperature. This is one way you could determine if you're outside, how cold is it going to get in my area? And there are some areas, if you are looking at the chart, that can be up here in Minnesota, in the northern part of Minnesota. We can get down to negative 30. If I'm going to be outside, I don't have a listed product that's going to work for me, I may have to look at one of these other alternative means of freeze protection. Now let's summarize it all up. I've talked about a bunch, and I'm going to get into a few exceptions in a moment. But let's actually just, again, let's reset ourselves. I went through a lot already. So we talked about why it's required, right? We know it's required in the document. But why is it in the document? That's because stuff can happen in antifreeze. I can get it diluted. I can think I have it in there, but somebody drained for repair and didn't refill it. Now all of a sudden I got no protection. Want to make sure we're not going to have burst pipes. We also want to be sure we don't have too concentrated of antifreeze where it's going to be a risk. Want to make sure it's compatible with the material we have. So we understand the importance of testing it. Document wants us at minimum to test it every year. And when are we going to do it? Well, let's do it right before we need it. Don't do it too soon or too late, right? We want to do it right before we need it, before the onset of freezing weather. If we review our information and it says, I don't think this is even a solution allowed, don't even bother testing it, just replace it. If it says, no, I think it is allowed, let's actually verify that. Let's get some samples, top, bottom, most remote water supply, if it's not part of the top and bottom. And we're going to get that tested. Again, you can do this in the field if you got a hydrometer, refractive index, or you can use a laboratory to help you. Again, I'll just make sure you know what you have. Get it tested, take those values and compare that. If it's a listed product, compare it to the data sheet. If it's a non-listed product, we're going to have to look up some charts available in the NFPA document and compare and figure out, well, what do we have here? If I have to drain it, I'm going to have to replace with this listed solution. But if I have an existing, it's already in the system and it's less than 30 propylene glycol, it's less than 38 glycerin, and that is enough freeze protection for me, that can remain in the system. So now we just got to, again, check it next year, check it the year after that. At some point, it's going to have to be replaced, whether that be for repair, internal inspection. You are going to, at some point, going to have to drain that and replace it. At that point, You cannot put in the legacy, the non-listed solutions. You would have to use a listed solution. And unfortunately, if there isn't one at the use temperature you need, we're going to have to look at those alternative means. Sorry, my voice is giving out a little bit here. Feeling a little bit under the weather. Now, last thing before we get, and we'll get into some questions, wanted to talk about some exceptions. Unfortunately, again, these NFPA documents are minimum standards. And then I always like to say, like, the English language, you always heard it's always I before E except after C. And then they give you a whole bunch of exceptions, like science. So it's the exact same thing here. I just went through, yeah, that all makes sense. Okay, now let's take it to the next level. It's complicated a bit. There are some exceptions. So the first one I mentioned there is for listed solutions, you can, and not even can, it says you shall, use the manufacturer's instructions for the number of sample points and refill procedures. So I talked about, okay, you want to take the top, bottom, most remote, near the water supply. Document says, follow the manufacturer's recommendations. If they say they want you to take it 5 feet from this point, you follow those. This one I don't think you don't got to worry about too much. If you look at the data sheets for the manufacturer, most of them say just follow NFPA 25. Or they'll list instructions and it matches what NFPA 25 has. Remember that these NFPA standards are made up of are produced from committees. Those committees typically have some manufacturer representation. So the knowledge, expertise does end up in both places. You'll notice they're very similar, but I did want to point that out. And refill procedure, that jogs my memory a little bit. Question, again, I'll look at the chat in a bit and see some questions. Question we'll typically get on something like this is, do I need to drain the drops in my system? So we did the testing and it was unacceptable, or we don't even know what's in here. We're just going to drain it and refill it. Do I need to drain the drops? I will reference you to the annex again and say that it says, typically you do not. Typically, the amount of antifreeze in the drop is insignificant. If it mixes a little bit with the listed solution, you're still fine, still acceptable. I have confirmed that with a few manufacturers as well. They are not typically recommending the draining of the drops. Now, the word typically is used because drops, obviously, as you guys know, if your contractor's on the call, they can vary, right? If we have a very long drop, if I have several feet in my drop, now I'm getting a lot more water. And if I got a lot of those long drops, maybe now that is a big percentage of what I'm going to put in. In that case, now, now we got to think more about, do I need to drain the drops? But again, I'd refer you to look at the manufacturer's data sheet. Typically, it'll reference NFPA 25 or use the same language, but let's always look at that. Another exception does say, technically in the document, where used to replace non-listed antifreeze solutions, listed antifreeze can be used outside of its listing limitations, provided the temperature range is not exceeded. So what the heck does this say? All this is saying is, look, we understand the listed products, there's only 4 of them, and they have their limitations. There's only been so much testing so far. You may run into a situation where this listed product, it meets my use point, right? Like let's say it goes down to -10, I only need it to go down to 0. So yeah, that'll work. But I noticed it says I can only use up to 40 gallons, right? The volume, there's a limitation on that. This is allowing you to go beyond that limitation. Like, look, my system is 41 gallons. You could use this antifreeze in that situation. There is a caveat. It's right in the document. It's not even in the annex, not even in the explanatory material. It's in the body of the document. And again, I think this is to try to bridge the gap of, look, we know there's only so many solutions on the market. We gotta have some flexibility here. Obviously, the one thing we can't be flexible on is that use temperature. Will do you no good if it says -10, but I need to go to -12, close enough. You do not want to be in that situation. You do not want burst pipes and all that damage. Another exception is I talked about with propylene glycol, we wanted those to be at most 30%. There is I believe it was FM, actually had a technical report on K25 suppression mode sprinklers. The title was K25 suppression mode sprinkler protection for areas subject to freezing, if you want to look that up. But essentially they found, like, look, ESFR sprinklers, they're putting out a lot of water. If you have greater than 30% propylene glycol, there's still a lot of water being pushed out. You might be okay. As long as it's listed for such use, someone's evaluated, that's been acceptable, that's safe, you can, your exception, you can go beyond that 30% limitation. Again, I think that's a more rare situation, but it is something to keep in mind, especially for your storage facilities that are using ESFR sprinklers. If for some reason your storage facility is cooled, it's in a freezer, there may be, you know, some gap there, some flexibility where you can use more than 30% propylene glycol if you need it. Let me go back to my chart real quick, and this will show you kind of how to use that chart. 30% propylene glycol, that gets you down to 11 Fahrenheit. Again, if you needed to get down to 0, now you're high 30, probably 38% propylene glycol. Typically not allowed, but if you got ESFR and it's been listed, it's been proven, tested that it's safe, you might be able to use that higher percentage in that instance. And the last exception, I brought this up once before, is that listed CPVC fittings and pipings, you're only going to use either a listed solution or a glycerin solution. You cannot use your propylene glycols and obviously not your diethylene, ethylene. Those aren't even allowed any system. But propylene glycol, even if it's less than 30%, you do not want to use that in CPVC. That is a compatibility issue. So those are some of your big exceptions mentioned in the document. I think at this point, yeah, that was what I had for the bulk of it. I'm going to just summarize once again. We know why we need to test it. Too little, burst pipes. Too much, ignition. We want to make sure it's the right type. We have compatibility issues. We're going to review the information. You know, hopefully we have that antifreeze information sign that's required. Hopefully we got that on there and we know right there if we, you know, we know what we have. Unfortunately, I mean, I understand records aren't always kept as well as they should be. You guys are doing your best. Ask the building owner, see if you can find other information, or utilize a lab like ourselves. We can tell you, well, here's what the product is. If you review that information and you already know it's not going to work, just replace it. Otherwise, you're going to sample it, test it, and see if it's in the allowable range. Verify it's in the allowable range. If not, you're going to have to drain it and replace it. The only thing you can replace with is listed product. If it's acceptable, if it's below 30% propylene glycol and less than 38% glycerin, those non-listed solutions can remain. So I think at this point, I've been seeing some questions come in chat as I've been going. So let's get to those. Let's use the rest of the time for you guys. So I'm scrolling through, and Jenny, if you're still online, feel free to ask them as well. How do I find out what addition my state uses? And it looks here, very good. Thank you, Joel, for chiming in. Yeah, there are links on the NFPA website, your state as well. You know, I think I could even Google it here and I can tell what edition of 25 states are on. Most, I mean, it's pretty rare you're on the current edition, 23, although that's been around for a little bit now. I would guess you're either 2017, 2020. Again, most of what I said is similar. The big change is that the old edition was actually more strict. The old edition said as of September 30th, 2022, all your non-listed solutions just need to go. There was no ifs, ands, or buts. The 23 editions actually said, hey guys, you can let those legacy, those non-listed solutions remain for a little bit until you need to drain them. As long as they're within this range, and they used to allow a little bit higher range. I think they allowed 38 glycerin. You could actually go up to 50, but you had to do this risk assessment. They kind of took all that out, but yeah, that's how you'd find. There are ways you can Google and find what edition your state's on. NFPA code finder. Should I be seeing something on screen? I hope now is probably not a good time to ask, Jenny, but you could see my screen and hear me okay, correct?
Yep, I'm on the thank you screen. I do have some questions I can read for you.
Go ahead.
The first one's from Matt. How critical is it that the antifreeze solution you're testing doesn't have to have contaminants in it? How critical is it that the antifreeze solution you're testing doesn't have any contaminants in it? If so, do you ever try and filter them out before testing?
It's fair. I mean, It really depends. If you're talking contaminants like solids, it's typically not too much of an issue. By the time we get it, we put it in our, at least here at the lab, the test tube, those will filter out. It can be an issue if you're, especially refractive index. Again, we're talking about light, how it's being refracted through the solution. Contaminants, whether it be visually, you can see some sediment or it's a different chemical. Yeah, that will change how it's refracted. So that could impact your results. It'd be pretty rare that a contaminant would perfectly match the solution. Where, typically it's like, hey, this looks funky. I would test it, see, nah, this looks funky. If you think, I think it's bad because there's a bunch of junk in it. Could you separate it out? Yeah, sure. But typically it's not. Typically it's not an issue, but could be.
Someone else is asking, can you supply a list of listed solutions, or did we mention it?
Yeah. But let me pull that back up here. I got to get. Again, I've
I'll
gone through
also
this.
send everyone a link to a few things, including the PDF of the slides, so you guys will have access to these.
So again, as of Monday, the 18th, I went to UL's website. So I believe this might be the only one, at least here in the States. This is a standard, this document here, UL 2901, is how we're listing them, this document says, here's how we're gonna test it, here's the requirements. When I look up what products have passed that, it's these four. You have Lubrisol's Freeze Master, Novel's Firefighter Eliminator 1330, and Tyco has two. They have the LFP, and then they have an enhanced version going down to -25. So those, it's four listed products. Consult your distributor, consult these manufacturers. And again, there's more than just, I know everybody's interested in how low can it go, but there's more than that. You want to look at what it's compatible with, minimum design pressure, system volume limitations. That there's more to consider that. I'm not going to get into that myself, but I would recommend reach out to the manufacturer and they will certainly be able to help you. Here's what our product's listed to. And then remember that exception, we love exceptions in life, that it says, hey, if you're replacing your non-listed solution, some of those compatibility you don't want to mess with, temperature you don't want to mess with, but some of these volume limitations, you may be able to skirt around those. There's that exception there. It can be used. Doesn't say you shall, it says you can, you could use it outside of its listing. So again, the slides will be provided on screen. It's for listed products.
From Emily, while you are able to give us a thumbs up or a thumbs down, if it is a listed solution, don't we also need to know the type of listed solution?
Yes. Yeah, I can tell you what, hey, this is thumbs up, this is Tyco LFP, or thumbs up, it's Noble. Yeah, I can tell you that. Typically, a lot of times we'll get samples and they, hey, I think this is Noble Firefighter 1330, and I'll give a thumbs up. Yep, it matches, or thumbs down, no, it doesn't. But if it's thumbs down, we'll typically tell you this actually looks like this listed product. Or most cases, it's, hey, I don't even think you have, either you don't have a listed product at all, or it's just diluted. Maybe you did, but you can't even tell because it's been diluted. The water supply's leaked, or maybe you don't even have antifreeze. Someone drained it, you didn't even realize, refilled it with water. But that's a good question. Yeah, we can. I can't tell you again all the ingredients of it, but I can give you. Yep, it's one of those four products.
Does listed antifreeze require to have an expansion tank?
I believe so. I'd refer you to the manufacturer. Um, these listed products are similar to legacy non-listed solutions. They may have a few additives and whatnot for, there's obviously things that they test for at the listing. They want to make sure it's going to be safe and effective. But in the grand scheme of things, they're somewhat similar technology, which if the expansion tank was required with legacy, it probably isn't listed. But in the installation of it, I'm not an expert. I do not want to go out on that limb myself. I'd refer you to whatever antifreeze you're going to install. If again, you could look at their data sheet, they're really good with their installation requirements. Otherwise, reach out to them. They'd be happy to help you on that.
What is the benefit to using Dyne Labs for antifreeze testing rather than doing my own testing using a refractometer?
Okay, yeah, the benefits, again, beyond the Dyne difference, I would say, hey, we can do it quick, free kits, free shipping, but I can do that really quick in the field. I don't need shipping and whatnot. You need to know what you have if you're going to use a refractometer. And let me go back to that screen where I had, again, you have a refractometer, or let's say a hydrometer, just because the chart on screen shows specific gravity. So you put it in your little device, you get a number. Again, the example I used is you get a number that says 1.029. So you're going to go to your chart if you're doing this yourself, and you're going to go, oh, I have 10% glycerin. Or you can come down here, or do I have 38% propylene glycol, right? So you need to know, again, you're going to look at that information, you got to figure out which one do I have. Where Dyne can really help you there is we can determine which one you have. We have higher end analytical equipment. We're able to verify, yep, this is glycerin, this is propylene glycol. We can make that differentiation. So that's really one of the biggest beyond the listed. Again, if you need to verify that, but it's really, you don't know what you have. Again, chemical tests, we fall under that. Chemical test is something you can use to figure out what you have. Other people have found they just don't want the liability. They want someone else. Some customers trust, like, I trust a lab more, whether that matters to you or not. I don't want to maintain equipment calibrated. So again, you bought this meter, but it's 10 years ago, you should calibrate that meter periodically. That's some stuff we can help you with. But really the biggest I see is, look, you can certainly do this in the field, but you got to know what you have. And you're not going to be able to tell what you have just by having a refractometer or a specific gravity. You're checking just one of those. It could be either or. I have one here, Jenny, I could read out. I see someone asked, is Dyne now owned by NFPA? So I briefly mentioned at the beginning, we were acquired by NFPA Global Solutions. So NFPA Global Solutions, this is about a year ago we were acquired, is a separate nonprofit entity owned by NFPA. So technically we are owned by NFPA Global Solutions, which is owned by NFPA, the nonprofit. If we want real quick, we can talk about why that is. Why does NFPA Global Solutions exist? You notice I mentioned they are a for-profit entity. NFPA as a nonprofit had some limitations. They saw a need for a for-profit entity to do some things they could not do to better serve the stakeholders. Something like this laboratory, what we're performing, this function is meant to serve the NFPA stakeholders, right? Your contractors, all of you listening, just would not be possible under the nonprofit org. So they made a for-profit entity. I think that was announced in March of last year, and we were acquired in June of last year. So that's just quick and dirty. We can get into that more if you want to, but technically we are owned by NFPA Global Solutions, which is owned by NFPA.
Thank you for covering that. In a pinch, are there any physical indicators that can tell you what is in the system?
Physical indicators, I mean, refractive and specific gravity, but we already talked about the limitations on that. Just looking at one of those, you could have either or. There is some dye, some manufacturers put dyes into their agent, but it's not a great thing to go off. I know some are colorless like water, but then they get in that rusty pipe, they turn orange. One of the manufacturers is using an orange dye. So I would say no, I don't think that's a good way to go about it. A visual inspection, just physically looking at it to know what you have. Again, if you have good records or you're pretty sure, checking the refractive or specific gravity, I mean, that's why it's allowed, is that can be a good physical property to check. Just you gotta be sure you know what you have. I see one here, Joel. Again, thanks for chiming in earlier. He also said your inspector goes off taste. Would
Yeah, I
not
saw
would
that
not
one.
would not recommend that. But yeah, that
I'm
is
hoping
not a
that's a
physical.
joke.
Yeah, yeah, definitely. That is not a physical property we want to check. Contaminants, solutions. Go ahead,
Is it
Jenny. If you got
expensive to
more.
get an antifreeze sample tested by the lab? We can reach out to you with pricing. I have your email, so I can get that out to you.
Yeah, we can get you pricing. I mean, for a laboratory, I think it's relatively inexpensive. I mean, I want to say it's close to $100 sample, but it's a bit more if you need that higher end, that listed verification. But if you're just looking, hey, is this propylene glycol or glycerin? That's not relatively too expensive. The specific gravity test
Oh, go
says,
ahead.
yeah, sorry, the specific gravity test says 77 degrees Fahrenheit. Refractive index is temp compensation. What is the offset difference? If so, is it negligible? So this person's asking a good, or mentioning a good point that the values I'm referencing, and oh, look at this, I'm right on the right screen. They're referencing, you'll notice the specific gravity and refractive index listed here, mention the temperature. That is an important parameter. As you get colder and hotter, that can actually change these values. I would say it's slight. Now, if you're in the middle of the range, which the manufacturer shoots for, you don't set a QC spec and try to make all your product on one end. Ideally, you set a spec and you fall in the middle. So typically, a couple degrees isn't going to make a huge difference. But if you are testing this outside in Minnesota and you're down to 0 or less, this says 25 Celsius, there could be some changes. What exactly are those? I don't have those off the top of my head. I think we did get some data at some point, some temperature differences. If you want to know more, and Jenny, this is one maybe I'll follow up with later, and maybe
Okay.
we can send an email later. Like I have some old chemistry textbooks where it kind of talks about and has some refractive indexes and densities at different temperatures. I could do that for propylene glycol and glycerin. I can't do that for listed products. They're just, they're a little bit different chemistry, but at least could give you a sense on how much it varies. So that is one I'll have to follow up with you. But great point. Yeah, these do matter on temperature. Typically room temp's 20 Fahrenheit, you could test it like that. If you're outside somewhere, I don't think it's going to make a major difference, especially if you're in the middle. But if you're on the edge and you're like, wow, it's actually a lot colder, you might be okay. Let me get back to you on that one.
When checking with the Palm Abbey or whatever you have to test, should you wait until the antifreeze is warm, or can you test it right after you pull it from the system?
I mean, that question kind of relates right to the last one about temperature. Um, the temperature can change the refractive index and specific gravity a little bit. Again, I don't think it's major, but we will follow. Everyone that registered, Jenny, maybe I'll send an email. I'll pull
Okay.
some data, and here's what I found from 0 or -20 all the way up to, I don't know. I'll see what my textbook goes up to, and I'll give you some data. So that one, stay tuned. We'll send an email on that one. Where is the verbiage, we drain all drops? So this one, Linda, you must, sounds like they drain all the drops. They wanted to see where that verbiage is. So if I could right now, I'm actually going to stop sharing my screen and or my PowerPoint, and I'm going to share just my screen if I could. Give me 1 second. I'll actually show you where I'm getting that verbiage from. Screen one, share. So what I'm showing on screen here, NFPA link, if you haven't used it, it's a nice way to be able to access NFPA standards, search them and find them. And on NFPA link, I've looked up NFPA 25, and again, I got into the 23 edition. In the annex, so A, you'll see A534. So annex is always explanatory material. It's shoulds instead of shalls, right? It's not enforceable. It's just there to help explain it. And then in here, do I have the ability to, I don't know if I can annotate it, but it is 1, 2, 3, 4 paragraphs down. It says where systems are drained in order to be refilled, it is not typically necessary to drain drops. Most systems with drops have insufficient volume to cause a problem, even if slightly higher concentration solutions collected in the drops. For drops in excess of 36 inches, so 3 feet, consideration should then be given to draining those drops if there's evidence that it was an unacceptably high concentration in those drops. So that could be a risk. If we have a 3-foot drop and we left that high concentration in there, that's the first thing that's going to come out in a fire if that sprinkler broke. So that's actually where I'm pulling it. I don't know if you can see me highlight it, but that is exactly where, again, from the annex. And Linda just chimed in something here. Let me see. I was told the listed solution cannot mix at all with old solution. I thought the same thing too, Linda. I'm right there with you. I actually asked. I don't remember which manufacturer it was, and it's probably been a little while. I asked them specifically because this with legacy I get it, but listed I thought okay, it's listed. They're very precise with those formulations, but I was told there too they weren't concerned about it, at least back then. So I would, again, I'm going to point you at this point to the manufacturer's installation instructions. But yeah, I remember at one point I had the same thought you did about, yeah, there's no way that you're going to have to drain the drops, which is a pain, right? Now you got to pull every sprinkler, right? You're not allowed to reinstall the sprinkler. So I get that's a huge pain. So what I tell you is just, again, especially you, Lynn, it sounds like you've been doing this. Just double check with your manufacturer, whatever antifreeze you're going with. And if they recommend, maybe they have new data or by all means, I support it. There, no, you cannot mix it. Then by all means, you shall follow their instructions. I'm actually going to stop sharing this screen and pull back up my PowerPoint. But no, it was a great question, Linda. Thanks for asking that again. Like I said, I was right there with you. It's a question I reached out to the manufacturer pretty quickly on in the I was probably not till 23. And yeah, it's a thing to follow up with.
Chris asked, so per NFPA, it's not stated in the code due to the sunset date. If a building does not have any documentation, it needs to be replaced.
So is it not stated in the code that does not have any documentation and needs to be replaced? It depends. I mean, is it not stated in the code, the sunset date? So again, we're talking about that sunset date no longer appears in the 2023 edition. Now they just say you have to use listed product. If we're past that I know what you're talking about. That's September 30th, 2022. The previous editions put that as, hey, we got to switch over to listed. In the 23 edition, they saw not everybody's going to make that date. They're not going to get it all switched. So they allowed existing to remain, provided it's at these concentrations. If they do not have any documentation now, documentation is just one way, find my pointer again, is just one thing you're looking for. Let me go back to that. Yeah, you want to have that information sign, installation records. You could, again, if you don't know what you have or you think it's legacy, you could have us test it. We'd provide you documentation. We'd give you a report that says, here's what you have in your system. Yes, you have Lubrisol's Freeze Master. Or no, you have this legacy product and it's at this concentration. It's acceptable. Now you got to verify the freeze point's okay for what you got going on. Again, I can look at those isotherm lines, but I don't know, maybe you're in a freezer somewhere. Like it all depends on your application. But that sunset date, it's a tricky one because yes, at your state, you look up, it requires this document. It says after this date, it needs to be replaced. Well, the most current edition actually says it can actually remain in there, provided it's acceptable at these new parameters. So it's a bit of a gray area. I mean, if you want end all be all, you follow to the letter of the law, yeah, you can go and it says to replace, we got to replace it. You're going to have to eventually, at some point, the system's going to have to be drained, right? Or repair, internal inspection. You're going to have to at some point replace it. So you're just delaying the inevitable. I don't think, at some point it's going to have to happen. But there are ways. NFPA, again, when you say NFPA says this, it depends which edition we're on and what about documentation. Even if you lack documentation, they do allow, we could give you documentation. We could test it and here's what you have. Now, we may give you something and here's what you have. And by the way, it's not acceptable. Doesn't mean any edition. But I hope that kind of answers it.
What are the potential risks of using antifreeze that hasn't been properly tested for both freeze and boilover protection?
The risk of using an antifreeze that hasn't been properly tested for freeze or boil over, I mean, it's the same. I mean, it's the basics, just safe and effective. One, is it going to protect my system? Am I going to have water damage, costly water damage? And when we talk about safe, we're really talking about ignition. Because again, antifreeze, unfortunately, by nature, the stuff we know, what we call antifreeze, what that is just, it's an additive we put in water, a chemical, and it just, that chemical happens to lower the freeze point of that water. That's a property it has. Unfortunately, all the chemicals we find that do that, well, they just happen to be flammable liquids. So it really sucks. You know, we found, hey, we can lower the freeze point, but the negative is, hey, this is ignition risk. So that's why there's these limits. So I mean, if you missed at the beginning, how do we end up such strict requirements? It used to be much more relaxed. As an individual did perish. I think this is the late 2000s, I want to say, maybe early 2000s, where concentration was too high, system was under a lot of pressure as well, so it made very fine droplets. Just a very explosive, very flammable situation. When it kicked on, I believe it was over a stove. The fire, instead of the water hitting it and kind of controlling it, it boom, burst right away, right? The first thing coming out is antifreeze. Now, eventually, as the water runs, it'll push all the antifreeze out and you'll have water. But the first thing that hits it, you have this ignition. And that individual did perish. It forced the industry, the committees to look at this and go, we need to put some more requirements, more restrictions. And to your point, let's have these things evaluated by a third party. And then UL was one of them. Like, okay, we'll make a standard. Here's, which again, when I say UL, they're also made up of committees, experts. Here's the things we should test. Let's test the flammability, the ignitable. Let's test the corrosion. Want to make sure it stays in solution. Again, back in the day, you might, hey, I got a 30% solution, but as soon as you put it in the system, it separates out the water, and the propylene glycol would sink to the bottom, the water go up top. Now we got a problem. So those are the dangers we're talking about. Is, I know most people think about, are my pipes going to burst? That's obviously a danger, but the other danger is, if I do have a fire and this little bit of water right above the sprinkler water seal, that stuff comes out first, is that gonna fuel my fire? You wouldn't think so, right? You don't want it to, but that's the challenge we're at with these antifreezes, is those chemicals can do that.
We're just about at time here, a little over. Do you want me to dig through and find any questions we didn't answer, or maybe a few of them, or we can get to you guys, back to you guys individually as well?
Yeah, I mean, I don't mind. People can obviously hop off if they need to, but I'll answer a few more. I see. Are we still flushing the systems of water before recharging with new antifreeze? That one, I'm gonna send you the manufacturer as well. I would think if they're not draining the drops, they're probably not making you flush, but that's a great question. I would check with the manufacturer, or maybe some others on the line know or have a typical procedure with that.
So another code question, does NFPA require a test drain valve on the high side of a system? End of a branch line on a system, question mark.
That's a good question. Again, I'm not an expert on installation, but you're gonna want something. I don't know if it's required or not, but yeah, if you got an antifreeze system, you're gonna want to be able to take like that most remote portion. You got to take a sample. You may want a test port there. You may not want to have to pop a sprinkler off, or however you're gonna get that sample out of there. Whether it's required or not, I'd have to look back at it.
Do you use a refractometer or a hydrometer when you test a solution at the lab?
Oh, we have both. Yeah, I mean, we don't use hydrometers anymore. We have density meters. I myself too. If you can afford it in the field, it would probably be better than the hygrometer. So again, the hydrometer, it's like a buoyant buoy. You know, you set it in the water, but you can get digital meters now. How does it work? I think the density meters use electrical current and vibrate something. It's pretty technical, but that's for density and specific gravity. They're related. Refractometer, we use a benchtop unit, so like the handheld one I talked about. 3 digits, maybe 4. We can go out to 5, much more precise. We have ion chromatography. That's definitely not something you'd have in the field. I don't know if we want to get too in depth on that, but it's got a column and you put the liquid in and that column's able to separate. And then coming off the end, you can quantify via conductivity. But do we have those, can we check specific and refractive? Yes, I mean, that is part of our procedure, our report. You would get refractive, you get the density, so you have that information, the freeze point, pH if you want it. Again, we didn't talk about that at all today, but something we can easily add on, and most contractors are asking for it. So that does not impact your pass fail, but we do give you the pH as well.
Again, if anybody was watching in a group, I was just going to type you guys a message and you need a certificate, feel free to reach out to me with a list of people watching and I'll make sure you get those. I'll probably send out certificates mid next week. If you don't receive one, please feel free to reach out to me by email. I'll put it again in the comments and let me know. It'll also be on the follow-up email that's going out today with a PDF of the slides and a link to the recording. Do antifreeze systems require backflow protection? If so, how should we note this on our reports and where would we cite this?
Again, that's going to be more of a design installation question. Don't want to act like an expert myself on that. You ask the manufacturer. NFPA 13 and look at that. Do you know how the manufacturers come up with acceptable refractive index ranges? Not 100%, but I'm imagine they are making solutions at different concentrations and they know, like if they advertise, hey, this is down to -10, they know, hey, I can protect down, and that's a use temperature, not a freeze point. There's usually a safety factor. So if they say you can use it down to -10, usually it's not rock solid until, I don't know, 14, 12. There's a couple degrees safety factor. So I would guess what they are doing is they are making up some mixtures going, hey, I think with that safety factor, we can go from this percent to this percent, and that equates to these refractive index ranges.
I think we covered most of the questions. Do you have anything else you want to summarize or?
No, I'm kind of glancing through. I think, yeah. So again, there's a bunch, which you guys, using the chat, helping each other. That's great to see. Again, not an expert on the design installation side. Check with the manufacturer on those. But there's one thing I will follow up with you all on. It was refractive index or specific gravity based on temperature. Give you some idea how much it varies based on temperature. So I'll get with Jenny to send an email out to everyone that attended, or maybe even everyone that registered. Just here was a follow-up question. Here's some information, some extra information I provided.
Do you want to throw up the end screen so we have your contact information? I also just dropped my email in the chat window, so that's available to you guys. And again, I'll try to get that email out today with the follow-up from the webinar, and then maybe a secondary one with the information that Grant wants to include on that.
Yeah, and the information on screen again, the Dyne.lab, very general. If you want to send directly to me, you can go grant.lobdell@nfpaglobal.com. So it's that same nfpaglobal.com, and I can go back, show you my name.
We can pass questions along to you as well if we get them.
Yeah. If you go to that other one there, but that's how you spell my name. But we'll put that up, the last slide again, just so you have that contact information.
Thank you, everybody, for sticking with us till the end. We appreciate that. We'll send you a survey and appreciate your feedback and any future topics you'd like us to cover. We'll also send a link over the recording, as I mentioned. Our next webinar is scheduled for Wednesday, October 15th, and we're going to be featuring our new stainless steel drop master DM25. It can help you easily replace sprinklers with its patented siphoning system. Helps remove trapped water and drops. Helps you improve productivity and profitability. There'll be a link to register for that webinar in my follow-up email as well. Watch the Dyne website, our LinkedIn or Facebook pages, and our monthly newsletter. for any future webinars and information on these type of things. Thanks again for joining us today, and we will see you next time.
Thanks, guys. Take care.